Hi, this lesson is about simplifying square roots. So what's a square root? The square root of a positive expression that we'll call x, and it is an expression whose square is x. So let's talk about numbers first. So all of the numbers that you see here, these three columns, are considered to be the principal square root of each expression. And you should definitely memorize these if you don't already know them. These are called perfect squares. So 1 is a perfect everything. It's a perfect square, a perfect cube, a perfect fourth. But I still listed it here. So the square root of 1 is 1, square root of 4 is 2, etc., all the way up to square root of 144 is 12. There are more square roots, like square root of 169 is 13, but these are the ones that will show up the most in problems, so make sure you know them. Just some notation is here. The square root symbol is this one that almost looks like a division sign, except it's got this little tail here. That's your square root symbol. The expression on the inside, or the expression you're taking the square root of, is called the radicand. If you're taking the square root of a negative number, well, you don't get a real number result. So if you encounter any problems in your homework where you're taking the square root of something that's negative on the inside, your answer will be that it is not a real number, because it is impossible to multiply two numbers twice to get the result on the inside. So for example, square root of 64, that's equal to 8, because 8 squared equals 64. But with negative numbers, you can't square a negative number and get a negative result. So not a real number result. Okay, so let's take the square root of a positive number that is not a perfect square, meaning not one of the ones in the list above. When that happens, you're going to get something called an irrational real number. An irrational number is a number that cannot be expressed as a fraction or as a whole number, but instead it's a decimal that doesn't have a pattern, doesn't repeat, and it does not terminate. So examples of that would be like square root of 3. If you put that into a calculator, the number would fill up the entire screen. This actually goes on forever. So this curly equal sign means approximately equal to. So square root of 3 is approximately equal to 1.732. Square root of 7 is also not a perfect square. And again, this is just an approximation because this goes on and on forever. Square root of 26, this is also an approximation. So that's why we use that curly equal sign. So what happens when you have variables? It is possible to take the square root of a variable expression. So if I start with something really simple and I said, what's the square root of x squared? Well, what do you multiply 2 times to get x squared? That would be x. And what if I said, what's the square root of x to the fourth? Well, what do you multiply 2 times to get x to the fourth? That would be x squared. So there's a pattern with these, which I'll explain, because the variables are actually really easy to do. When you take the square root of a variable expression, if your exponents are even, then they are divisible by 2, and that's a square root. So I have 2 here and 4 here. If you divide both of those by 2, that will give you the result of the square root. So that will give you x to the first power and y to the second power, and it comes out of the radical. And again, that's because if you were to multiply this twice, so xy squared times xy squared, that gives you x squared y to the fourth. Okay, so let's look at number 2. I have the square root of a squared b to the 6th. So again, the exponents are even, they're divisible by 2. So in order to get the square root of that, you just divide each exponent by 2, and it comes out of the radical, and so you get a b to the 3rd. Let's move on to number 3 here in blue. I have the square root of 9, x to the 6, y squared, z to the 10th. Okay, so I have a coefficient of 9, and then I have all my variables. All of the exponents in the variables are even. Okay, so the square root of 9 is 3, because 3 times 3 is 9. Square root of x to the 6 is x cubed. Square root of y squared is y. Square root of z to the 10th is z to the 5th. Okay, let's move on to number 4. I have the square root of 64, a to the 8th, b to the 12th. Square root of 64 is 8. Square root of a to the 8th is a to the 4th. Square root of b to the 12th is b to the 6th. Again, all you're doing is dividing your exponents by 2 because it is a square root. The square root means that the root is 2 of this radical. All right, so let's go on to number 10. Number 5. I have a 10 as a coefficient in front of the radical. So anything that comes out of the radical will just get multiplied by 10. So this expression is the square root of 4a squared b to the 10th. I get 2ab to the 5th, but then you have to multiply the 10 and the 2, so you get 20ab to the 5th. Okay, here's another one with a coefficient. Negative 2 is outside of the radical, so anything that comes out of the radical gets multiplied by negative 2. So the square root of 36b to the m to the 4th n to the 16th is 6m squared n to the 8th. Multiply the negative 2 and the 6, and you get negative 12m squared n to the 8th power. Okay, so not all square roots are perfect squares, but oftentimes you can still simplify them. So let's start with just some numbers. So I have the square root of 12. So although you can approximate that with a calculator, there's actually a way to simplify them by using what you know about factors. So we're looking for two numbers that multiply together to give you 12, where at least one of those factors can be simplified in terms of taking out the square root. So with 12, you have a couple of options. I have 2 and 6, and I have 3 and 4. So 2 and 6, it doesn't help because 2 and 6 are not perfect squares, but 4 is. So I rewrite 12 as 4 times 3. Now what is the square root of 4? Square root of 4 is 2. So that comes out of the radical, gets written in front of the radical, and then the 3 stays inside the radical because it's not a perfect square. All right, so let's do another one. We have 28. With 28, you can rewrite it as 2 times 14 or 4 times 7. Again, 4 times 7 is the one that we want to choose because the square root of 4 is 2. That comes out of the radical. 7 is not a perfect square, so that stays in the radical. So your answer is 2 root 7. That means 2 times root 7. Okay, so here is number 3. This is negative 2 root 80. So the negative 2 is on the outside. 80 can get written, there's a couple of options. I have 4 and 20, and I have also 2 and 40, and I also have 5 and 16. Okay, so 4 is a perfect square, but you want to pick the biggest one possible because then it will simplify further. Because notice that 20 still has another 4 in it. So that's the same as 16 times 5. So we rewrite it as 16 and 5. The square root of 16 is 4. That comes out of the radical, which is what you see here, and that will get multiplied by negative 2. And then the 5 stays in. So your final answer is negative 8 root 5. Okay, now let's introduce some variables. So here we are at number 4. Remember, with variable exponential expressions, you want even exponents. So x squared is even, but here the 5 is a problem. But I can break down y to the 5th as y to the 4th times y. Because what do you do with exponents when you multiply? These are being multiplied. You add, so 4 and 1 gives you the y to the 5th. So this line is equivalent to this line. They are equal to each other. Now I'm ready to take the square root of x squared and y to the 4th because they have the even exponents. So the square root of x squared is x, that comes out. Square root of y to the 4th is y squared, that comes out. But the y is not a perfect square, so that stays in the radical. Okay, let's try another one. Number 5, I have a cubed, b to the 4th, c to the 7th. B to the 4th is a perfect square. A cubed and c to the 7th is not. So I write a cubed as a squared times a, and I rewrite c to the 7th as c to the 6th times c. Again, because these two add up to c to the 7th. Then everything with an even exponent comes out of the radical, and you divide the exponent by 2. So the square root of a squared is a. That comes out. The square root of b to the 4th is b squared. That comes out of the radical. And the square root of c to the 6th is c cubed. So that comes out of the radical. And the part that's left inside is ac. Okay, number 6. Here I have the square root of 32 x cubed y to the 12th. So here I have a combination of coefficient and variables. So my variables are fine. Those are both divisible by 2. I don't need to worry about rewriting them in a different way. But 32 is not a perfect square. So remember, there's a couple of different ways to write 32. So we have 4 and 8, and we have 2 and 16. So the biggest square root is this one. And you want to choose the 2 and 16 because if you chose 4 and 8, you would still have to break down the 8 into 2 and 4. So again, 4 and 4, that multiplies to 16 times 2. So you write that as 16 times 2. So this is x, oh sorry, I misspoke before. I need to break down the x cubed. That's not even. So I rewrite that as x squared times x. The y to the 12th is fine. So the square root of 16 is 4. That comes out. Square root of x squared is x. That comes out. Square root of y to the 12th is y to the 6th. That comes out. And you're left with 2x inside of your radical. Okay, let's move on to number 4. Number 7 here on the right. So I have 27a squared b to the 9th. We need to break down the 27 and the b to the 9th. So 27 gets rewritten as 9 times 3 because 9 is a perfect square. The b to the 9th gets rewritten as b to the 8th times b. So now we're ready to take the square root of 9, which is 3, and the square root of a squared is a. The square root of b to the 8th is b to the 4th, and 3b stays on the inside of the radical. Okay, here's another one. 75 m to the 5th, n to the 11th, p. All right, so everything needs to be broken down here except for p. You can't break down p more than what it is. So factors that will give me 75 that has a square root in it is 25 times 3. Rewrite m to the 5th as m to the 4th times m. Rewrite n to the 10th time, n to the 11th as n to the 10th times n. And then there's the p. All right, so the square root of 25 is 5. That comes out. Square root of m to the 4th is m squared. That comes out. Square root of n to the 10th is n to the 5th. That comes out. That's what you see here. And then the parts that stay in the radical are the 3, m, n, and p. And that's it. So that's it for that lesson. You should try the homework for 13.1. Good luck.